Hi students, today we are going to discuss about one more important 5-mark short notes. It is actually an intermediate of glycolysis. The question name is 2,3-bisphosphoglycerate, or sometimes they are asking in some like MGR University 2,3 hyphen capital BPG, like what is the role of or short notes on 2,3-BPG, like that they are asking. So 2,3-BPG means 2,3-bisphosphoglycerate. Actually the normal level of this one is 4.5 plus or minus 0.5 millimoles per liter. This is very rarely asking MCQ question, but you just go through 4.5 plus or minus 0.5 millimoles per liter is the normal level of 2,3-BPG. Okay, number one, where it is synthesized? It is synthesized in erythrocytes. What is the cycle name? Rappaport-Lubering cycle, one of the intermediate in product in glycolysis. RL cycle is, in glycolysis, usually the 3-phosphoglycerate is synthesized from 1,3-bisphosphoglycerate. That is step number 7. Here the enzyme is phosphoglycerate kinase. We need one ADP which is converted into ATP, right? Whereas in Rappaport-Lubering cycle, this ATP utilization is compromised, right? So the 1,3-bisphosphoglycerate is first converted into 2,3-BPG. Then with the help of phosphatase enzyme, it will be again converted into 3-phosphoglycerate, which is finally converted into pyruvate. This is the fate of glycolysis. Okay. So for this 2,3-BPG, in glycolysis, how it is synthesized, how it is not present. That means 7th step we have to explain. In RL cycle, how this 7th step is modified. That is, production of 2,3-BPG will occur in RL cycle. So you have to explain two steps. One is from glycolysis, another one is from RL cycle. Right. Next one is, what is the role of this 2,3-BPG? It always regulates the binding and release of oxygen from hemoglobin. Then only the delivery of the oxygen to the tissues is very easily they can deliver. That is, unloading and loading of oxygen. You know the meaning of loading and unloading. It delivers the oxygen to the tissues, right? Next, what are all the conditions for the synthesis of 2,3-BPG in high amount? Okay, we have 4 conditions where the 2,3-BPG is increased synthesis. This is for the compensation of the reduced oxygen supply. This is very important. We have 4 conditions where the 2,3-BPG synthesis is increased to compensate the decreased or reduced oxygen supply in these 4 conditions, right? What are all the 4 conditions? One is high altitude, second is obstructive airway disease, third is anemia, fourth one is HbF, that is fetal hemoglobin. In all these 4 conditions, oxygen is decreased or supply of oxygen is decreased. So the BPG level is increased to compensate the reduced oxygen supply. For all the 4 conditions, the only mechanism is to increase the oxygen supply. The 2,3-BPG is increased, right? Next one is the elevated level of BPG, that is 2,3-BPG, which lowers the oxygen affinity of hemoglobin. This permits greater unloading of oxygen in the capillaries of the hypoxic tissues. So first you have to mention these 4 conditions. After that you have to describe only one point, that is elevated 2,3-BPG levels where it lowers the oxygen affinity of hemoglobin that permits greater unloading of oxygen in the capillaries of the hypoxic tissues to compensate the reduced oxygen supply. Right. Second, in blood transfusion, this is actually some Viva question or MCQ question, that is why I want to give you. In blood transfusion, usually the stored blood, it has low level of 2,3-BPG level. This low 2,3 BPG level decreased the ability of transfused blood to deliver the oxygen to the tissues. So decrease the supply of oxygen will be there in the stored blood. To prevent this, we have to add inosine, that is INOSINE, inosine, otherwise known as hypoxanthine ribose sugar. It is nothing but purine nucleoside, one of the purine nucleoside, which is converted to BPG, that is 2,3 BPG by RBC. Here only one explanatory step is this inosine, INOSINE, that is hypoxanthine ribose sugar inosine, where ribose sugar is released, then phosphorylation occurs, the sugar enters into HMP shunt. This produces glyceraldehyde 3-phosphate, glucose 6-phosphate and fructose 6-phosphate in HMP shunt, which automatically enters into the glycolysis where it will synthesize 2,3 BPG. This is a mechanism in the stored blood to prevent the low level of 2,3 BPG. Okay, very important point for your stored blood. Next one is, what is the difference between HbA and HbF? Actually, HbF means the composition is alpha 2 and gamma 2 subunits, that is tetramer. This type of hemoglobin is having greater affinity for oxygen than hemoglobin A, that is adult hemoglobin. Because hemoglobin F doesn't bind to 2,3 BPG as hemoglobin, that is adult hemoglobin does. Therefore, the growing fetus is also to take its mother's oxygen from her bloodstream directly. This is the advantage of fetal hemoglobin for the baby's oxygen supply.